Hi, everyone, and thank you for attending this session. My name is Priel, and I am the VP Product at Ermetic. Let me tell you a little bit about the company. Ermetic is a cloud security company with a unique spin on securing your public cloud deployments. Ermetic does more than just check for misconfigurations and compliance violations. It also looks deep into the environment and helps organizations understand identities and tame the complex world of entitlements. With that being said, I'm going to spend the session diving into the fascinating world of identities in the public cloud, their entitlements, and how to improve your security posture.
So let's get started and look at what we call the anatomy of an entitlement. To fully understand an entitlement, we need to understand four components. The first is the entity. This is going to be either a machine or a person. The second is the identity. This is going to be a specific identity that the entity has access to. In AWS, for example, this could be either a user or a role. As we already said, these identities represent the entity, but we need to remember that the identities can be used by both human and non-human entities. Other important consideration around identities we should remember are that identities could, for example, have loose credentials like access keys, that a user might have security requirements like multi-factor authentication or a specific password complexities. With a machine, we need to understand what their exposure looks like and if that machine that is assuming that identity is internet facing or not. The entity that is assuming that identity could also be a third party, like an external security vendor that was actually granted access. The identities might also be grouped for management simplifications. And the last thing is the identity might be able to assume another identity in the environment. This could either be the user assuming a role or even a role assuming another role. The next component we need to understand is the permissions granted. The permissions can be as simple as the ability to read data or write data, but they could also be much more specific, like the ability to list the contents of a bucket without the ability to read the contents. Or the permission might actually define what the identity can't do. A permission can apply on multiple identities and resources. It could contain wildcards and condition. It could be assigned as broadly or as tightly as needed. Like the example I just gave, the permissions don't have to grant access. They can also restrict them. Lastly, the permissions can exist both on the identities and on the resources, as I mentioned before. Like with the identity component, we need to remember that not all permissions are equal. For example, a permission can be created and controlled by the cloud service provider, really limiting control an administrator has over the actual policy. Not to mention that the cloud provider can choose to change that policy at any given point without notification or any warning that it is actually changed. The last component is the resource. And this is just another entity. But more specifically, this is the entity we would like to interact with. Some example of resources are containers, databases, load balancers, or even encryption keys. I know I've said it multiple times already, but a resource can have its own permissions and can be directly exposed to the internet. Now, after that long explanation, let's look at our two examples. For the first one, we have a person using the user 12345, and he or she can actually read and write data from drive marked EE11. This example is fairly straightforward and really easy to understand. In the second example, we have a virtual machine that is using the role 14312, and in this case, the permissions specify that this identity can't delete from the resource marked BA14. Again, this is not an overly complex example, but just aimed at demonstrating the machine identity concept we all hear about so often. So now, this image we see in front of us tries to explain really the complexity of entitlements based off of what we talked about in the previous slide. We can see all the different considerations we need to consider when calculating the entitlement of a single entity. We can have a scenario of a federated user that has the ability to assume a role that belongs to a group and has both permissions at the group level and attached to the identity itself. On top of that, we might have a policy that limits that specific role's actions even if they were granted to him. Now, what happens if that role has the ability to assume another role in the environment? That role might not even be in the same account or subscription as the original role. What happens if the second role has access to a resource because of a resource-based policy? All this needs to be taken into consideration when looking at the entitlements for a single identity. Now, what happens when you have multiple entities? What happens when you have multiple identities? This just grows exponentially and becomes very difficult to understand and track. So, if I were to try to map all this out, we would end up with a graph that looks something like this. You can see that we might have multiple entities represented here by the identity provider, the external entity, and the service entity that can all assume a single identity. Now, this assumable identity has permissions attached to it, granting it access to a specific resource. That permission is also attached directly to a user and to a group. That user also happens to belong to that group and might even have the option to assume their original identity as part of the policy. Now, all these identities have access to a resource, as we said, but that resource has its own policy that might allow access without any consideration to the actual IAM policy. So as we can see, just with this small environment, we end up with a good few options of access between a single identity and a single resource. What I personally think this graph doesn't do really well is it really doesn't explain how many possibilities exist when examining a standard size organization's environment and trying to understand the entitlements in that said environment. I would have no way of manually sifting through it all, even to start formulating a good understanding of what's happening there. So hopefully I managed to explain how complex cloud entitlements are. Now, let's talk about the problem that exists because of that complexity. At first, we have to talk about the scale. Like I mentioned in the previous slide, a small environment might have a few identities and a few resources, but it will still have thousands of permissions. Trying to analyze the entitlements each identity has requires a lot of time and a lot of effort. More so, the personnel that is needed to map and understand these entitlements are fairly rare, and because of that, they're fairly expensive. Now, this becomes an even harder issue with the constant changes an environment goes through. A lot of these environments are constantly modified via different automation processes. That means that it's not always easy to even track the changes, and you would need to consult different teams and members to understand what must be reevaluated. Again, every change might have a chain reaction, so examining multiple components would be required. If the cloud providers themselves offer tools that would truly help with the process, that would already be a better situation. But the tools that they offer today are not granular enough. They don't pick up all the entitlement intricacies we talked about earlier. And lastly, they are manual and require a user to run and consume the findings to perform any type of remediation. So with all that being said, I'd like to go over a case study that I'm sure you all heard about. This public breach that occurred in 2019 to a large financial organization that, without going into all the technical details, really the large financial organization deployed an app. In this specific case, it was actually a web application firewall. The deployment had two inherent issues. One with the security of the application, and the other was with the permission set granted to that said application. The first issue was a vulnerability that the attacker could use to compromise this specific application. In this specific case, it was a server-side request forgery vulnerability. The vulnerability allowed the server to be tricked into running commands that it should never have been permitted to run, including those that allowed it to talk to other services in the environment. The other problem was the unrestricted access this application had to the other resources in the environment. Those specific permissions also included access to a sensitive bucket that contained really a lot of customer information that was deemed as PII. From there, the story is pretty obvious. The attacker compromised that application and used the permissions that were granted to that application to traverse the environment, gain access to that bucket, and exfiltrate millions of customers' records. Needless to say that this data exfiltration could have been avoided if the permissions were clear to the responsible team. So looking at this specific case study, we can see the toxic combination that led to this breach. The exposed machine, the overprivileged identity, and the lack of control on the sensitive bucket. As I mentioned before, this could have all been minimized if the permissions were understood and reduced. Again, I'm not saying that the breach could have been potentially blocked altogether, but at least the blast radius would have been much smaller. So that organization is not really alone. According to a report published by Gartner, 50% of security failures are a direct result of inadequate management of identities, access, and privilege. That number is only going to keep rising and is expected to reach 75% by 2023. Think about it. That is a staggering number. 75% of all breaches will be really a result of just mismanagement of the identities. So all this led both Gartner and Forrester to come up with market segments for solutions that come and address this specific problem. Gartner named theirs Cloud Infrastructure Entitlement Management, and Forrester named theirs Cloud Identity Governance. This really just goes to show the importance of the problem and the fact that the current cloud security solutions don't adequately address this issue. So now that I showed a case study and hopefully explained the problem well, what is actually missing or what is needed from a tool to actually come and solve this problem? The first thing really is visibility. The tool needs to be able to discover all the entities in the environment across all the accounts, providing really unmatched visibility and understanding into all those entities and their behaviors in the public cloud infrastructure. This should also include, for example, access patterns of the federated users. So actually monitoring how they behave in the public cloud infrastructure. The granularity of the details is really key here. You don't want a tool that could only analyze the permissions to the service level or just to a handful of services. The tool has to be able to visualize the access to the lowest level possible. From there, we really move to the analytics. This is where the tool needs to take all the data around the entities and start analyzing it to understand all the different access policies, the usage patterns, and really identify any risk in the environment. This is where you take all the data that you discovered from the deep visibility and make sense of it, really to formulate an actual needed policy, or what we refer to as the least privilege policy. The last thing that is missing and needs to be addressed is really the policy enforcement. This is where you take those risks that you discovered by the analytics phase and that were brought up by the visibility, and you surface them really in an easily consumable fashion. You have to allow anybody to understand the risk and really all the needed steps to remediate them. This should also include the option to remediate through the actual tool. It is really crucial so you're not just left with more alerts that you need to figure out and really try to understand how you go and triage them. Now, one thing that I would say and add that is missing from this slide is that if the tool can look and help with your general security posture and actually tie it back to the identities, that is extremely valuable. Just like in the specific case study that we saw before. You want a tool that can come in and really explain the actual blast radius and what could happen if a public machine is hacked in this specific case and has access to an identity that is overprivileged.
With the remaining time that I have, I want to take a quick look at the Hermetic platform and how we can help address these gaps and more. We are now looking at the Hermetic platform. To set the stage a little bit, this is a demo environment that we have that is connected to several AWS accounts, some Azure subscriptions, and right now the product is reflecting the entire environment that we have connected. The Hermetic solution itself is a SaaS solution, so there is no real installation that's needed. There's just a simple process of connecting it to the environment. Usually takes about a few minutes. Now, as we said, one of the biggest issues is really trying to tackle and understand the identities and the entitlements that they own, and really going and solving that, and in general, improving your cloud security posture. So what I'll do is I'll walk through the product fairly quickly. I'll show some of the biggest highlights that the product offers, and try to give you guys a glimpse in how we at Hermetic actually come and solve this problem. So I'll use the widgets in the dashboard to kind of guide me through some of the more interesting features, and I'll start off with the Identity Intelligence widget. So here we can actually start getting a glimpse into the identities that exist across our environment. We could see that we have, in this case, 536 identities, and we can actually see how these identities are actually classified by the system. So we have the critical, high, medium, and low classification, where critical are identities that actually are administrators or can elevate their own permissions to administrative access. High, as another example, are identities that have access to what we deem as sensitive permissions across the environment. So they have the ability, for example, to destroy the environment. They have the ability to delete virtual machines and so on. You'll notice that in each one of the sections we specifically call it the third parties, because these are of course more unique identities to the environment because they exist in the environment, but they're actually used by somebody external to your organization. Now this is really the highest level of data, and from here we can keep diving in. And I hit the show more button, and this takes me to a secondary page, and in this specific case it takes us to the identity intelligence page under the analytics menu. And now we can see the list of all the identities ranked from the riskiest identity to the least riskiest identity. We can see the makeup of identities. Like we can see that we have a predominantly, like a huge amount of service identities compared to the rest of the identities in the organization. And then we can get additional context right away around each of the identities. Like we can see that the top identity is an IAM role, and this is the riskiest identity identified in the organization. And it has excessive permissions, it is an administrator, it has anomaly detections associated with it. And in addition, you can kind of see the categories of the permissions that Ermetic discovered that this identity owns. So it has the ability to escalate its privileges further, perform permission management, data access, infrastructure modification, and so on. The second identity is actually a IAM user in this case, and you can see some information like that it has no MFA, and that it even has access keys associated with it. Now we can keep diving in even further, and we'll click that identity, and now this has moved us into inventory, AWS, IAM roles, and now we're looking at that specific identity. We can get the general information around this identity, like the fact that this is the entity that can actually assume this identity, like when it was last active. We could see all the alerts associated with that identity, which I'll talk about further in a bit. And we can actually see the effective permissions of that identity. So this is the visual representation. So this is an actual graph that represents the permissions that this identity owns and all the access that it has to all the different services. So we could see the identity here on the left, the different policies associated with him in the middle, and then on the right, all the different resources that it could actually access. Now, as we said, this is one of the more complex issues, and Hermetic does this fully. It takes all the different policies into consideration, regardless of the complexity behind it, and it does it automatically. Now, there is another view that is a table view that allows you to view the same data just in more of a list format, but we'll go back to the graph view. And if you remember, we said that this identity, Hermetic classified that it has the ability to perform privilege escalation. It is already an admin, but just to kind of demonstrate, we can go into the categories, select the privilege escalation category, and then this will filter the graph to show us the possible paths of privilege escalation. Now we can make this more interesting and say, okay, we want to see what he could do to other accounts. And then we're left with this image where we can actually see that this identity has the ability to go and assume these other identities that exist within other accounts in that environment. And of course we can go and check each and every one of them and see that it's actually true, and we can see that in this case he has the ability to assume this role, and from there he can actually migrate into a different account altogether. And you can really slice and dice the data any which way you want. Now, the next window is just a general activity window for this identity. So these are all actions taken by this identity, and anything that it did or anything that was done to it would also show up in here. And the last thing is actually configuration snapshots, which shows you all the different revisions of policy that this given identity had. Now, we could do this not just for the identities, but we could do this for resources as well. So if we want to look at, for example, an EC2 instance and understand its interaction with identities in the environment, as we said, we have to understand this not just for humans, but for also machines. So here we can actually go to the EC2 and look at its specific entitlement. So we can see the machine, and then the identity that it can assume, and then of course all the different resources that it can interact, and of course the color that shows you what is excessive and what is not. Now, if we jump back to the dashboard quickly, we said that we have the identity intelligence, but now the excessive permissions is really one of the more complicated issues, and really where Ermetic wants to try and help solve that problem. So we can see here that this environment is fairly excessive. We have about 78% of the total permissions in the environment being excessive. And then they're categorized into different buckets. You have some excessiveness that's derived from inactivity, like inactive service identities or inactive users. And then you have some that's just because of overprivileges granted to a given identity in the environment. It could be directly to the identity or also via a group. Now, we could go in and dive in deeper and actually see the details behind all these numbers. So I click the show more. This took us to the analytics, excessive permissions page, and now we're looking at all the 210 inactive service identities that exist within this environment. And again, you have all that visibility that we saw in the previous page. But here, for the first time, you actually see the remediation button, which I'll touch in a few seconds. But to make this a bit more interesting, let's go to the overprivileged service identities. And look at one of the identities that we understand is overprivileged. We'll look at the identity that we looked at before. We'll jump back to its page, and now we'll actually focus on the findings. So we have two alerts for this. The first one is unusual data access, which is an anomaly-based detection. So we understand that this identity has performed access some data that it has never accessed before, so we raise an alert. But the alert that I want to focus on more right now is the overprivileged IAM alert. So what we try to do is we try to keep all alerts, regardless of the type of alert, in the same format. So you have the alert up top, you have supporting details in the form of this text and the graph that I showed before, and then in the bottom you'll actually see the remediation steps needed in order to solve this specific alert. Now let's look at this alert and see, we can see that this specific role, which is called users, has administrative access, the administrative access policy attached to it, granting it permissions on 255 services, but it's only really using 65 services, and out of those 65 services, it's only using some permissions on 6 services. Okay, we can see additional information like the fact that this was active 6 hours ago, so we know it's an active identity. Now at the bottom, let's jump to the remediation steps and actually look at what Hermetic is suggesting that we do. So on the left side is the current policy that we have for this identity. And we know it's an administrative policy, so you can see it has all action to all resources. So basically it could do anything to anything within this environment. On the right side is the automatically generated policy that Hermetic suggests as the least privileged policy for this given identity. And you can see that there's a lot more information in here, because what it's doing is it's actually giving it that access to the services that it's using. And you can see for some of the services it's granting it full access because it is using all that access. But to some other services it's actually granting it a lot more specific access, like S3, where it's calling out the specific permissions that it needs. Now, any place that Hermetic can be specific, it'll be as specific as possible. And that'll also include even calling out the specific resources that might need, that this identity might need access to, as opposed to leaving it to all resources. Now, from here, we could really just click the remediate button and have the Hermetic solution itself go and fix this issue for us. It'll actually take all these actions. Or we do have an option of integrating with some CI/CD tools like Terraform and CloudFormation, where you can actually push this out and use those. Now, one of the unique points of Hermetic is not just really being able to tame the excessiveness, but as I said, is also helping you around the cloud security posture in general. So the two bottom widgets really touch this, which is the misconfigurations and the internet exposed resources. So we can see that we have some misconfigurations in the environment, and we can see we have a lot of different resources that are publicly exposed. We could see all the rules under the policies engine, and then go to compliance in the specific case, and we'll see all the different rules and all the different failures that we have. Let's just focus for quickly on one of these internet exposed resources. So let's hit the internet exposed resources. This will filter that view to show us all the different resources that we have that are publicly accessible. And let's look at the EC2s. And let's focus on the first one, which has 34 EC2s that are publicly accessible. And just go and pick the first one. So when we look at the EC2, we have the network tab where we can actually see the representation of the connection. So we see that this is actually open to the entire world through a load balancer to port 80. But tying this back to the privileges is what makes it very interesting, where we can see that this given machine has access to this identity that we're already telling you is privileged. Has access to different S3 buckets, it has access to a lot of different resources in the environment. And again, we can understand quickly that the blast radius here is going to be much more significant if this machine gets compromised because of the overprivilege that this specific resource has. Just as an example, we see here the 45 KMS keys. So let's do a quick filter and see if this actually has the ability to decrypt the KMS keys. You can see that it does. It actually has the ability to go and decrypt these 44 KMS keys, meaning that anything that is encrypted via these keys could actually be decrypted. Other than that, I would say from the misconfiguration perspective, we do support all the standards that you would expect out of a compliance tool. So it could actually support CIS. I can show you a list. So really anything that you would expect. But as I said, the idea was really to come and explain both what we could do around the identities and the excessive permissions and how we tie that back into cloud security posture in general. I know this was really quick, but I really appreciate the time everybody spent listening to me. I thank you all, and we'll open it up for questions now.